here at Astricon 2016 to talk to you about handling multiple requests to Redis, to Asterisk using Redis. Well, I'm going to talk a little about me and my work. I'm a computer systems engineer. I work as PIP CTI Senior Leader System Administrator at Price Travel Holding. I'm from Mexico. Let's talk about my work. I work at a travel agency, but we like to think that we are a technology company. So we have been growing up very fast. When the company started, the company had at in the year 2000, 20 employees. We were having an average calls per day, like 200 calls, and maximum concurrent calls, 10 maximum concurrent calls. Then the year that I started working at Price Travel, the company had 600 employees. We had 3,000 calls per day, and we were having maximum current calls 120. The next year, it was very interesting because we decided to grow. We were on little houses working, and our contact center was in a different location than our server's location, the developer's location, and we decided to move to a big building for us. And that year, we integrated a company in Mexico City. Our current location, the corporate location, and the main contact center is located at Cancun. In this year, the company had 1,000 employees. We were handling 4,000 calls per day average, and we had maximum concurrent calls for 240 calls. The next year was also interesting because two companies from Colombia integrated with us. Now, at that year, we integrated a company that had another contact center at Cali, Colombia, and another company that had another 2 contact centers. At that year, we were handling 6,000 calls per day average. We had 1,300 employees and a maximum concurrent calls of 450 calls. Now, this year, we're handling like 8,000 calls per day average, sometimes more. We are 1,600 employees, and we have a maximum concurrent calls of 600 channels. That's because the physical limitation, and all across our contact centers. These statistics are only for contact center. We have also our corporate telephony system, and we provide service to another companies. So, the last year we were here, teammate and I were assistant to the Astricon 2015. We were meeting the guys from, the main developers of Dium, of Sangoma, the free PBX, and also we were having some discussions with another providers that we use their service. And we were happy at that time because we were proud how we could have all this infrastructure. We install this infrastructure, we configure it, we manage it, and we give it the properly maintenance that it needs. So the last year at the Astricon, we received the worst call someone can receive. Our boss was calling us and telling us that we had a big problem in the company. We have a big mess. So here's a graph. This is a graph of the CPU consumption on one of our main contact centers, on the main PBX for the contact center. And that day we have 3 problems. poor voice quality, choppy calls, high CPU usage of the PBX, and high number of requests to the PBX. So that day, we had to disconnect a lot of applications that we were using to the people working at the contact center, some applications to provide us statistics, and other applications just to visualize how the queues were the queues information and the calls information. When we returned back to Cancun, my team and I, well, at that year, I was the only one at VIP sysadmin team. And we are like 15 people, sysadmin people for a company of 1,600 employees. And we were trying to deal this problem with the developers. We have also a developers team that help us to analyze how the applications were behaving. So this was our system architecture before October of 2015. I'll try to explain a little. We have the PBX running MEI with Asterisk with CentOS. We have an Asterisk web service. This web service is running on a Windows server with IIS and the library asterisk.net. We were using this service to request data and actions to the PBX through a web application that we'll name Contact Center. This application is also on a web server and a Windows server with IIS. We make a little connection with an SQL server to display the information about agents or the queue names. So we can give to the client a pretty nice interface that shows the queue information and the status of the agents. This was a problem. We decided this was a problem because this application was designed for a contact center that in that time we were like 100 agents maximum. So we decided to work on a solution, a system redesign. So something that we have been arguing with the developers team is that they have to manage somehow all the requests that were coming into the PBX. So they told, well, in the discussion, someone proposed, well, let's make a queue where all the requests are being stored, and then some workers to be sent to the PBX. All those workers process a low quantity of requests to the PBX, and so you receive a lot of number of requests from the other applications, and you don't crash the PBX, and because you are using, well, you are making a lot of requests through the MEI. So the solution was to implement Redis. And, well, what Redis? Well, it's an NoSQL database system, and it has a great performance because all the information is stored in RAM, not in hard disk. Also, we can make a high number of requests and catching that request using queues. We can distribute the request processing by using workers, and also we avoid the degradation of the voice quality because the CPU usage. Also, we implemented Redis because it's simple to make this implementation, and it's very simple, its maintenance. Redis offers you a lot of tools so you can integrate your other applications to Redis. So you can make this kind of working schemas, and you can handle multiple requests. So the new system architecture that we proposed that time was, as you can see with red, these are the new models. We installed a Redis server with CentOS, and we modified our Asterisk web service. IIS is receiving all the requests, and all these requests are processed by the workers and are sent to the PBX. So you don't crash your PBX by sending a lot of requests. Okay. Unfortunately, I couldn't bring all the infrastructure and the code that we use in production in our company, but the last month I was building some kind of similar code on Python. I decided to call it a Asterisk web service. You can download it from GitHub. That's the URL direction. So the architecture that I practically made a copy paste from the other architecture, but I'm using a Linux with Python and PHP, so I can the same schema that we have on .NET and with Microsoft Windows server. We can use Linux and Python to emulate that schema that we designed. So we have here a request code that I built for a demo that I'm going to do right here. This request code is made to the Asterisk. I have here some Raspberry Pis. I'm going to emulate to process 1,000 requests to a Raspberry Pi with a PBX from another server where I have installed the Asterisk web service. So this code, as you can see, is not using a Python library to connect to the Asterisk. This code, I use an array that I define, and I send to the PBX through sockets. I send the petition, like I will connect to the console. And well, it's pretty simple, this code. Okay, so let's make a dangerous demo right here. I'll connect to my Asterisk web server. So I'm going to run a little code that I have here. This code will send 1,000 requests to the PBX, and I'm going to watch the CPU's consumption right here. Also, I'm going to make a call so you can hear how the voice quality is degraded by all these requests. So let's do channel originate, save 200, application, music on hold. All right. So let's make 1,000 petitions. I'm sorry. Okay. And as we can see, excuse me a little. I think I sent the, oops, sorry. I sent the wrong comments. Okay. I sent the command with Redis, sorry, so that's why the demo didn't work. Yeah, sorry. Let's wait a little so the all the command will end. Oops. That's nice. Okay, well, at least the other, oops. Well, let's see what does this code do. CD, that's the only trouble. Okay. Okay, let's run the other code. I'm sorry, my bad. Okay. Come on. Okay, now I'm going to, it's processing the other command. Oops. Did I tell that was a dangerous demo? Okay, let's wait a little. Yeah, the server is working on the other petitions. Well, while this is being processed by the server, I'm going to show you the request code with Redis. Here I use a library that is called RQ, that it handles the queues with Redis, and it's easy to implement. The only thing that we have to define is our Redis connection, the queue that we are going to use. I'm using here the default queue, and this is the worker code. This worker connects to the queue. No, this is the request code, sorry. This is a code that connects to the queue and sends a request to the PBX. In this case, I'm trying to send the command core show hints. So the worker, well, this stores the command on the Redis server, and then the worker can read all the jobs that have to be processed on the queue, and it finds the job and processes it. Let's see if this can, oops. I promise this was working. Okay, I'll try to make, yeah. I'll need to reboot this server, so wait me a little. So I'm just restarting the server. Well, this is the request code. You can integrate this request code to your application. It's very easy. In the code that you can find on the GitHub is using Flask server for Python. So it's really easy to get this working with Python and your web server application. And here we have the Redis worker code. The Redis worker code, well, connects to the Redis server, and well, it requests all the jobs that are on the queue, and it processes one by one all the jobs that are pending. Also, you can start multiple workers, and you can define how many jobs you can do at the same time. And you can test it for turnout with your PBX, so you can process more jobs with your workers without making the voice quality to be very bad. Well, let me see if I have the server. Yeah. Okay. Okay. Let's connect to the server again. Okay, so let's try again this code. I hope the server won't crash again. And let's see the CPU usage. Okay. As you can see on the demonstration, the dangerous demo, the voice quality was degraded because all the requests that were made to the PBX, the CPU usage was high, and we were having all that troubles those days at the contact center, and we decided to use Redis to handle all the requests made to the PBX. So this is the next demo with the Redis working. Let's connect. I'm going to connect to the scripts. For the Redis to work with our to handle all our requests, we have to start a worker. So I'm going to start the worker. CD scripts. CD Redis. All these examples, I built some examples, so you can use all these examples into your PBX. All are without Redis, with Redis, and the final implementation for your web server with Python and Redis running, so you can make those petitions. So on this Redis, I'm going to make my worker to start. So the, ls. Let's see, Python engine worker. Okay, let's see why this is not. Yeah, I haven't grabbed Redis. I have to start my Redis service, so if I haven't my Redis, I can't do the requests. Now my worker is running. Now here I'm going to make all the requests. Well, this console was gone. Yes. I'm going to start another one. Restart this one. No, this one not. Sorry. Duplicate this one. Let's see if this is working. Just a little patience. So I start my worker, and then I'm going to use a monitor so I can see how many requests and jobs are pending on my PBX. So let's see, it's running. We have this monitor where I can see all the queues, the workers, and the jobs that are going to be processed and depending on the ones that were not processed. And now I'm going to make 1,000 requests with the queuing script. Okay, so I'm sending 1,000 requests. I have here my PBX. I have here my monitor, and I also can see here my worker. It's right now working. As you can see, we have the jobs being stored on the queues on the default queue, we send 1,000 queues, so it's processing all these requests. And the CPU of the PBX is normal. There's no high CPU usage to the PBX, and the code's voice quality is not degraded. So it's a simple implementation of another technology connected to the PBX to handle all these requests that are made through the AMI. I know there's a lot of people that say to me, why you don't use AREI instead of MEI? Well, we have a big infrastructure, so we can migrate from Asterisk 11 to Asterisk 12, 13, now 14. And we have a lot of applications that we have to spend a lot of time and money and human resources to change all this schema to AREI. So this system architecture was built in less than 2-3 days with the developer team. We implemented all this in less than 1 hour, and it has been working for 1 year and 2 months. And well, it's working. That solution worked for us, for all of our applications, and we are happy with that solution. As I said, you can find this on the GitHub. Well, I have no internet connection right now. Sorry. Well, and the conclusions is queuing task avoids the applications, your other applications, and your PBX to crash. You can control how many tasks are being processed. So if you see that there are a lot of requests sent to the PBX, you can also decide which to run and which not to run. You can get metrics like time statistics about how the tasks are processed, and you will avoid the degradation of the service, the VIP service. And well, that's what we did at Price Travel. And well, I want to show you the web server that I have with Flask and Python. You can download it. You only have to start the worker, and you only modify your application with Python or whatever you want, and you start to use all this implementation. So, thank you very much. And